Okay, so this is chapter 8, Parametric Equations. To make sure you can really access this one, you need to make sure that your trig from chapter 6 and chapter 7 is very, very good. Otherwise, you're going to find this chapter quite difficult. So it looks like quite a small chapter in the book, but it's deceptively difficult. Here are the main parts of the chapter. So what we're going to do is we're going to start with talking about what parametric form is. And how this compares to Cartesian form. So Cartesian form is really what you've been working with so far. It's about y equals some function of x normally, or some combination of x and y's. So parametric form, you'll notice that we have x and t, y and t again. So that's what this is all about. We're going to have a look at, I'm going to break that up into two parts. So there's an easier and a more difficult part. And then we're going to talk about how you could draw these kind of curves. So for example, this thing here, we can draw what that looks like as one curve. Points of intersection, lots of simultaneous equations here, not too bad. The modeling can get quite difficult. So let's make a start. So what are parametric equations all about and what's their purpose? Well, this thing here on the board would be very, very difficult to draw using just x and y. Do you notice how there's sort of two rules going on? So horizontally, you can sort of see some sort of sine or cosine wave or something like that going on. And then as we look vertically, we can see the gaps between as it oscillates back and forth getting bigger and bigger. So we've sort of got two things going on at the same time. And parametric equations allow us to draw more complex things like this, which could be quite useful if you were trying to model maybe like a spring or something else. So that's why you might want to do it. And we've got sort of a very basic example here on the screen of what a standard question could be. Quite a basic starter question though. So how could we convert these parametric equations, so that there's two equations, into a single Cartesian one? So a Cartesian one is only going to have y's and x's in it, no t's, no third letter. Typically it's t, sometimes it's theta as well. So what we could do is we could do a bit of substitution. So this one here on the left could be turned into t equals x over 2, couldn't it? And then this is the same t as is being discussed in here. It's the same variable. So instead of y equals t squared, we could put this result in. So y equals x over 2 all squared. So y equals x squared over 4. So this thing here that looks quite complicated in two separate equations is actually just the same as a quarter x squared, or x squared over 4. Anything else? Well, yes, there is one other thing. There is a restriction here about the values that you can get for t. So what that means is you wouldn't necessarily be able to draw this whole graph. It might only be parts of it. And we can investigate that by looking at some values of t and the values of x and y. So what I'm doing now, by the way, is a way that you can sketch what's going on sometimes. So you would do this with your calculator. You do a table of values on your calculator. You would call this one f of x, and you call this one g of x. You'd write in your equations, and then you'd substitute some points so you could find out what's going on. So it says from -3 to 3, but not including those values. Well, it's quite a good idea to look at what's happening at those values anyway. So you could do something like this. You could have a look as t goes from those values, and then you could substitute these numbers in to see what's going on. So x equals 2t, so that's -6. In fact, let's just do all of these quickly. So 0, 2, 4, 6. So horizontally then, you're going to occupy values sort of between -6 and 6. That's what my table of values is telling me when I'm going to draw this in a moment. How about y? Well, the rule about y is you square the values. So what's that? 3 squared is 9. So I've got 9, 4, 1, 0, 1, 4, and 9. So that is a bit like a coordinate then that we'll end up drawing at the end. -6 and 9. -4 and 4, -2 and 1, 0 and 0, 2 and 1, etc., etc. So if I wanted to go one step further and I wanted to draw this thing, I need space from -6 to 6, I don't actually need a bottom part because for y values, do you notice I don't have any negative values? So I could put -6 and 6. Let's put 0 there. It's symmetrical. You can see that it's symmetrical. And its minimum point is at 0. So remember, it's quite difficult for me on here to sketch the curve nice and accurately. But what you would have is you would have a quadratic going down at 0 and then going back up. And if you want to make it really correct, you could actually make these parts here sort of hollow to show that we're not allowed those values, are we? Look, the inequality says you're not allowed to use -3 or 3, so it's between those values. So that would be the complete graph drawn. So the bit I was doing at the top, this bit is the Cartesian bit, so I've turned it into a Cartesian equation. And the bit I'm doing below is I'm sketching it as a table of values, which comes up later in the chapter as well. And this is just a nice thing to do if you want to know what's going on. And it also kind of illustrates that point that it's not fully y = x²/4, is it? It's only between the values of x. So it's only between the values. In fact, let's write it as an inequality. It's between -6 and 6. Okay. That's the domain, isn't it, of the finished graph? That's what that bit would normally be called. So the idea is that the t values affects what the overall thing looks like. Let's keep going. So we're not going to draw this one. We're going to have a go at the Cartesian part again this time. So x equals the natural log of t plus 3, right? Y equals this here. Okay. And the rule is that you're only allowed to use t values bigger than -2. So the general technique, whenever you have any like plus, minus, divide, multiply, blah, 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 including natural log and e, when you have these kind of operations done, like you've got here, you just substitute. So it's a substitution question. You don't always have to substitute so that it's, you know, something about y. It doesn't have to look like this, for example. It just has to only have x and y in it, unless the question says anything in particular. So find a Cartesian equation of the form y = f of x. There we go. So this question does have that extra restriction. You should only have x's and y's in it, and the final answer should say y equals. Okay, that's what that bit means. So I'm going to have a little think about what the best way of doing this is. So which one do I want to substitute? I think I want to get t on its own from this. So if I raise both sides as a power to e to the x equals t plus 3, and e to the x -3 equals t. I think that's what I want to do. And now that's ready for me to substitute into the y equals equation. So let's write that one out. Y equals 1 over, leave some space for this, plus 5. So the reason why I'm doing this is it makes it very hard to make a mistake by missing something out. There we go. And -3 plus 5, that actually just simplifies to +2, doesn't it? So the final answer is y equals 1 over e to the x plus 2. That's the goal, because it's y equals and it's only got x in it, t. So this kind of like third parameter t has been removed. Okay. So the other part here is we have to say what x has to be bigger than. So up here it says x is bigger than some value, and we need to find out. So probably the best place to investigate is this t value up here. So why does t have to be bigger than -2? Let's play around with it. So if you put -2 in there, you end up with the natural log of 1. Okay, and you're going to find if you type that in your calculator, it's going to say math error. Okay, because it's not possible to take the natural log of 1. So the natural log of 1, well, try this on your calculator. Try something like that, and what will you get? So if you try something just a little bit bigger than -2, you would get something just a little bit bigger than 1. And this is going to be quite close to 0. So what it's telling you is that you can't have x values that are 0 or smaller. So the answer to that bit is actually going to be x is bigger than 0. And the way you find it out is from taking the condition, so the restriction about t, using it with the relevant equation. So we've used it with the x equation because that's what this bit is about. And although you can't see what that value is because it's not defined, you can get close. You can get close to the value by sort of just like adding on or taking away a little bit to work out what's going on. That's one way that you can do it quite quickly with your calculator. So we have now done part A. Okay. So that was actually about x, and now we've got write down the range. So the range means what y values can this thing take. So now we want to be looking at, well, you could have a look at the final version, but it's probably easier to look at this part here. So what values can you get from that, bearing in mind that t must be bigger than -2. So we're going to do the same thing again. We're going to investigate what happens at -2. So if you use -2, you'd get 1 over -2 plus 5. So you get a third. Okay. So if you get a third, well, what happens when you use numbers that are bigger than this? Let's try t. So that's t as -2. Let's try t equals 0 and see what happens. So you get y equals 1 over 5. So what's happening here is the value of t is going up. So you've got a third, or 0.33, etc., if you like, and then you've got a fifth, which is you've got 0.2. So it seems as though the values have to be less than a third. In fact, they can't quite take the value of a third because you're not allowed to use -2, but at -2 it would be a third. So a third going down to 0.2. Let's try a really big number. Let's try 100. What if t were 100? Well, it'd be 1 over 102. So again, it's just a very, very small positive number. Could it ever become 0? Can you do 1 divided by something and get 0? No. So what that's telling me then is that your y value is trapped between a third, and it's not allowed to be a third because you can't take the value of -2. But at the same time, it has to be bigger than 0. So you're only ever getting values between 0 and a third. So it's quite sort of vertically, it's quite restricted. It's quite short just between all of those values there. Whereas horizontally, it only exists to the right-hand side. Okay. In fact, we could draw this. Let's have a go very quickly at drawing this one so you can get a better idea what's going on. So x equals the natural log of t plus 3. Okay. And what was the rule about y? Y equals 1 over t plus, was it t plus 3? No, it's t plus 5. Oh, right. So that's what the separate graphs would look like. Okay, but what would the Cartesian graph look like? Y equals 1 over, so sorry, let's get rid of those ones. So y equals 1 over e to the x plus 2. Okay, remember we said we're only allowed x values that are positive. That was a restriction on t. So if we have a look here, there's the third, and then there are the other values. And if I zoom out, that's going to be an asymptote, isn't it? So that's never quite going to get 0. So it's quite an unusual sort of looking graph, but that's the nature of doing parametric equations, really. So it would be that part there that you can see on the right-hand side. Okay, that's what the Cartesian graph looks like. So if you have a graphing calculator, for example, you'll know then that you've got that correct. Y equals 1 over e to the x plus 2. X has to be bigger than 0, and that's the restriction about y. Let's pause the video and have a quick go, and then we'll do them on the screen. Okay, so this one says y equals f of x. So I'm going to rearrange the x part. So e to the x equals t plus 2. E to the x minus 2 equals t then. Let's substitute that into the other one. So y equals 1 over e to the x minus 2 plus 1, which is just going to go to 1 is e to the x minus 1. Okay, that's all you had to do on that question. This one here, let's do e on both sides again. So that's quite a common step really, isn't it? So y equals the thing squared minus 2, and the thing is e to the x. So it's going to be e to the 2x minus 2. That's all you're going to do for those ones. So substitution, if it's add, subtract, multiply, divide, natural log in e, you tend to go down the substitution way of doing it. Okay, let's stop there for that video then. So substitution with parametric equations, 8a is what we looked at.